Right. I don't have a warm-up problem today because we're already doing several different things here, okay? We need to talk about 1A on the new packet. We're going to do some examples on 1A. Then we're going to do some, like, 4 examples off the pink sheet, all right? And then there is an assignment that goes with, besides finishing the pink sheet, the assignment will be to do like 4 or 5 book problems and some more practice off 1B. I'm hoping we have time for me to just put the book problems up here so that you can get those because they're quick. So if you can get those book problems done, then you'll have part of the assignment done and you won't have to worry about finding a book. So that's the plan today. Okay. So we're going to start talking about reviewing some exponent rules. These are skills you need in Chapter 2. This first slide talks about, sorry, cursor issues again. Okay. This slide talks about rational exponents. Like if you have, messing everything up already, Hoffbauer. Come on. What's the deal? If you have rational exponent like 2 to the 3rd, does anybody remember what the top number does and what the bottom number does? Yes. Okay. So this is a cube root of x squared. Good job. All right. So here it says if you just have like n to the 1/5, it just means the 5th root of n. That's what this one says. But this says if you have, let's say, m to the 3/7, okay? It can be written 2 different ways, but the top number is a power, so it's m cubed, and the bottom number is a root, the 7th root of. It's also okay to say the 7th root of, oh, that was a squiggly 7, sorry. And then I'm going to cube it. The order doesn't matter. Sound familiar, all that? All right, then real quick review of exponent rules. I think we've kind of gone through these before, but if we have x to the 4th times x to the 3rd, we get x to the 7th. If we have x to the 12th over x to the 2nd, we get 10th, okay? Be careful, you're just subtracting. If we had y to the 5th, the 2nd, you get, yes, you're just multiplying these. You're not squaring the 5, okay? This one is important today. We're going to talk about negative exponents. If you just have x to the -6, that means 1 over x to the 6th. But remember, this can get kind of wacky. If we have an ab to the -2, it means what? Well, you could say they're both to the -2. What does that do? It means they both need to move, right? When I used to teach this way back in the day in Intro to Algebra, I used the phrase, cross the line, change the sign, okay? So if you want to get rid of this negative, you need to move the whole thing across the line down here and then change it to a positive. And this one needs to move up top and change to a positive. The trick that students forget is that if you have a 7x to the -6, the 7 is totally separate, right? This is 7 times x to the -6. So this would become 7 over x to the -6. Or 6, +6, just kidding. All right, and these two, remember, anything to the 1st power, just keep it. Anything to the 0 power becomes a 1. I hope you remember those. All right. Yeah, that's just more crazy exponent rule. I don't know why I decided we needed to explain. Oh, good, there's Anybody want me to go over it 6 different times with different tables? Yuck. I don't know why I got, what's this one? That's the one we just talked about too. Okay. I think we got them all. We're good. So we're supposed to rewrite these in radical form. How do we rewrite this as a radical? Anybody? What do you think, Tristan? No? Anybody? Okay, good job. It doesn't really say we should simplify. We could simplify a little bit, I think. Does anybody know why or how we could simplify? What is the 6th root of x to the 6th? Just x, right? 1x. So there's a 6th root of another x in here because there was 7 of them, right? So this is just an x, and then we'd have the 6th root of x. So this is, it's not in a quiz, okay? But you could simplify that. All right, what about this disaster? The cube root of 4x all to the 4th. Okay. What do you want to do first? Can't really cube root those things yet. So if we do this to the 4th, anybody know what 4 to the 4th is? Actually, I'm just going to write it that way for a second. We'd have a 4 to the 4th and an x to the 4th. Is everybody okay that that applies to both? Now, a 4 to the 4th, can we take some of these out if it's a cube root? Well, I'm not sure about the best way to explain this, but if it said 4 cubed with an extra 4 and an x cubed with an extra x, does everybody understand that that's equivalent? I didn't change anything. I just pulled one of the x's separate and one of the 4's separate. Okay. Well, what's the cube root of 4 cubed? Just 4, right? That would be the cube root of 64, which is 4. So this is taken care of. He's now out of jail. He's out here. And the cube root of x cubed would be x. And now left in here is still a cube root of a 4 and an x, right? Yeah, we're going to practice that a little today, but also not necessarily on a quiz. All right. When you have an even, okay. When you have an even root of an even power and the result is an odd power, you must use the absolute value to ensure that the answer is not negative. We're just going to pretend that little rule doesn't exist and not worry about it today because it's not going to apply to things that we do. All right. So I'll see if I find an example where that applies. But right here, what does the 1/2 power mean? Square root, okay? Just means square root. So now can we simplify that? What would happen? Square root of that is 8. Anybody know what happens here? Go back here if it makes more sense. What do you do with those two numbers? No. If it said n squared to the 3rd, you would multiply and get 6, right? So we need 6 times 1/2, which is 3. This is the kind of problem where you would actually need absolute values in theory, because no matter what kind of number I put in here for n, when I did it to the 6th power, it would become positive. Does everyone understand that? So in order to ensure that this answer is still positive and able to take the square root, whatever, I would need absolute values there, but we're not going to do it. We're not going to worry about it. Okay. Over here, what's the number outside? It's not a square root, it's what? Cube root of 8m to the 9th squared. But do you also remember I said you could write it like this? The squared can come first or second. And I think it would actually be, in my mind, we should make it smaller before we have to make it bigger. Because if we square everything and then have to cube root, those are big numbers. Because what's the cube root of 8, guys? Just 2. And what are we doing here? The third root of m to the 9th. So if I wrote 9m's, okay, and I wanted to take the cubed root, these 3, and these 3, what would I get? All right, let me explain differently. What power is a cubed root? 1/3. So if I just have an m to the 9th to the 1/3, what do I get? Yes, I multiply those and get m to the 3rd. See, if this was an m cubed, and m cubed, when I cubed rooted, each one of those would just become m. So I'd have an m times an m times an m, or m cubed. All right, got an m cubed here. I somehow made that very complicated, I'm sorry. Now we still have what going on though? Yeah, we got the squared out there. So now let's finish. What's that going to become? Don't forget to square everything in there. So it's 4, and you multiply the exponents, so it's 4m to the 6th. All right, the next section is about negatives in addition. It says your answer should contain only positive exponents with no fractional exponents in the denominator. And we're going to kind of eliminate that requirement today as well. But I'm going to show you what we would have had to do in the past. For right now, this is multiplication, so we could multiply in any order. What are the coefficients we could go ahead and multiply together? 2 times 3 is 6. How many x's do we have? We have an x squared times another x back here would be an x to the 3rd. Everybody good there? Okay. Now, one of these kind of belongs in the denominator, but really, because we're multiplying them, what are we doing with the exponents? If I had this, just as an example, you would add them, right? So we need to add these. Let's just add them. Use your calculator. What's 4/3 plus -1/2? You can use parentheses. Anybody good with fractions? We could get a common denominator of what? So this would be 8/6, and this one would be 3/6. So I'm getting 5/6. Did anybody add them on the calculator and get 5/6? Yes? Okay. So we ended up with y to the 5/6. Are we done? Says I should have only positive exponents and nothing in the denominator. There's no denominator period, right? So we get to be done right there. We don't have to rewrite it with a radical symbol or anything. All right, number 6, what are we doing here? How do we get rid of the parentheses first? Yes, we're going to multiply each of these in here. So the x to the -2 times 3 divided by 2 would be? It's -2 times 3/2. What does that simplify to? -3. All right, then the y is got a 2/3 times a 3/2, which simplifies to 1. So it's just a y. Then we still have all this on the outside here. Now what do we do? You want to move stuff to the bottom, or do you want to simplify and add your exponents first? The order doesn't matter. Okay, so how many x's? We had a -3 and a +2 here, so we end up with a -1, and we had a 1y and a -2y, so we end up with a -1. How do we finish if we're not allowed to write those with a negative exponent? Okay, so we have an x to the 1 and a y to the 1 on the bottom. So what's going to hold the fraction bar down? Just a 1. The order can be done differently, just so we're clear. All right, number 7. Oh, this one doesn't look quite so bad. What are we going to do with these lovely fractions? Multiply them, so we just get v to the 15/8. Good job. And then we have a u and a v to the 3rd. So our answer is going to have a u. But what do we need to do with these now? Add them together. So 15/8 plus 3, which would be 15/8. If we got a common denominator, this would be 24/8. Good job. So is that 39/8? Ugh. And you definitely could have used your calculator there. We're just leaving it. That's all we had to do. Number 8, I crossed off. All right, number 9, where do you want to start? Oh, you want to do this -2 to everything? All right. I'm okay with that order if you want. What do we get on top? And this little x over here becomes -2. This y becomes +4th. And x to the 5/4 times -2, which reduces to, yes, everybody getting that? 5/4 times -2 is -10/4, which reduces to -5/2. That's where we got that one. Okay, now what do you want to do? Like move some things around or add exponents, or I'm not, you want to add exponents? Okay. Okay, so if I combine those, because they're both on the bottom, -2 plus -5/2. Anybody get a -9/2? Okay, so I have an x to the -4th over an x to the -9/2 and a y to the 4th. Now what? Okay, you want to move them so they're positive? Okay, so these guys would move up here, and these guys would move to the bottom. Now we still can't have an x in 2 places, so, okay, what's 9/2 minus 4? These 4 will cancel 4 of these, and we have x to the 1/2 on top, and a y to the 4th in the denominator. Are we done? Can we be done? Yeah, because there's no fractional exponent in the denominator. So this is equivalent, just so we're clear, to the square root of x over y to the 4th. Now, how many of you would have done that in a different order? I would have, but hopefully we still would have all ended up at the same place. Does anybody need me to try it in a different order? Okay. All right. Was that 9? Okay. 10. What do you want to do this time? Get rid of those fraction, this denominator business first. What is 4 times 3/2? Yeah. Everybody okay that it's 6? Okay. Now what do you want to do? I'll do it in any order you want. Jada, what do you want to do next? Okay, so add those. So 2 plus 3/2 would be 4/2 plus 7/2. Did someone get that? 7/2 y to the -1/2 and x to the 6th. Okay. Now what? Okay. So what is 7/2 minus 6? Yep. Because it would be 7/2 minus 12/2 would be -5/2. So what does that mean? So there's more x's in the bottom, so it's going to end up with an x to the 5/2 goes on the bottom. If we could have written it on top, but we would have had to put it with a -5/2. What's the other thing that's happening though? The y belongs on the bottom as well. All right, so there's nothing on top, right? All right, you're not supposed to be able to leave it like that. Yeah, because this is, I'm just telling you, we're gonna stop here, but I just want to show you this once. If you simplified this, we have the square roots, right, of x to the 5th y in the denominator, and you can't have a radical in the denominator. Does anybody know how many more x's we'd need to make that a nice whole number? Yes. So if we left it like it is, we could multiply by another 1/2 an x on the bottom, and that would turn out nice. And how many y's would we need to make this turn out nice? 1/2. We do it to the bottom, we got to do it to the top. So we'd end up with x to the 1/2, y to the 1/2 here. But what happens here? X to the 5th plus another 1/2 would be 6/2 or 3. And a y to the 1/2 and a y to the 1/2 would be a y to the 1st. So this is really square root of xy over x cubed y with no radical in the denominator. But we're not going to do that. Miss Gupta said we don't have to do that anymore. You good? Yes. Okay. All right. That was just a little math team fun for you. Okay. Products of radicals. If you have like a cubed root of x and a cubed root of 6y, it's okay to combine them and get the cubed root of 6xy. All right, guys? As long as they're both cubed roots. And the same thing is true here. If you had the cubed root of 8 over x to the 5th, you could separate it as the cubed root of 8 over the cubed root of x to the 5th. Okay, as long as they're both cubed roots, you can separate them or combine them. So this is a book example. Ooh. Interesting. They're not the same, right? Let's write this as a fraction. This is 32 to the 1/10th, and this is 2 to the 1/6th. This is a gross question. I don't think you have one like this even on, but this is a power of 2. Does anybody know what power of 2 that is? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is 2 to the 5th. This is looking a whole lot better because now everything's got a base of 2. What can I do to these two up here? Multiply them, so that would be 5/10 or 1/2. Then what do we do? Subtract. We still keep the 2, but what's 1/2 minus 1/6? Can someone do that? This would be 3/6 minus 1/6 would be 2/6 or 1/3. So final answer, how could we switch that back to a radical? Cubed root of 2. All right, yep. I'm pretty sure that's not on the homework. This is on the homework. I think the easiest way to explain this is I could explain a couple different ways. You want to do with a fraction of 1/4? I'll explain it two ways, okay? I could do x to the 21, y to the 15th to the 1/4. So you'd have 21/4 and 15/4. That seem all right? The problem is you need to separate out the whole numbers. So what's 21/4? How many times does 4 go into 21? Okay, so it's 5 whole with what left over? 1/4. How many times does 4 go into 15? So you'd have 3 with what left over? 12, 13, 14, 15, 3/4. Yeah, I don't think this is going to be the way you're going to choose to do this. So we have x to the 5th and y to the 3rd. And then these fractional guys, we could put back under a 4th root. How many x's were under the 4th root here? 1 and 3 y's. Okay, I don't think that would be your first choice. How about if you just divide? 4 goes into 21. Here, let's do it this way. You could do an x to the 20 because it'll go in evenly, and then an x left over. And the y's, how many y's can you divide by 4? You can divide 12 of them with 3 left over. Okay, so now these 20 divided by 4 become an x to the 5th outside. And these 12 divide by 4 and become a y to the cubed outside. And left inside the 4th root is now what? These guys got out of jail. Y cubed. Okay, was that a better explanation? You like that one better? Okay, I'll use that one on the next one because you do have a couple of these tonight. This is also the kind of problem where you're supposed to put in some absolute values and we're just going to not worry about it. All right. So you want me to write it out separately like I did, or you want to just divide? Okay, so 5th root. So 5 of them we're gonna worry about, and then 1 is left over. What about an 8th? How many? So we're gonna have an x to the 5th with how many left over? Okay. Now y to the 10th divides evenly by 5, right? And what about the z? We're gonna have 10, because that'll go in there twice, and then we'll have 3 left over. All right. So the 5th root of, there's going to be some leftovers in here, but this, when I divide this by 5, I get a w. And then this guy stays in here. I divide this guy by 5 and I get an x. Now these 3 stay in here. Divide this by 5 and I get y squared. And yep, no y's left over. The z to the 10th divides by 5 and I get a z squared. And these 3 are left over. That's just disgusting. All right. Your assignment on this is to do on 1B, switch your worksheet over and circle the evens only. Right there, 1B, circle the evens. And I think we have time. Can I just flash these 5 up here before we start talking about the pink worksheet so you can get the book work done? Let's go for it. Okay, here's the 5 book problems. All right, so you can just write it on the bottom of 1B if you want. Is there room on the bottom, or even where the odds were? If you want to do it on a sheet of paper, you can. But this is page P17 in your book, which is chapter 0. Number 15. What do you think? Okay, so you'll have how many A's? But the b you're going to have to split out as, okay, so the 4 divides into 8 twice, but then we still have a 4th root of b left over. What? This should be a 2. Yeah, thank you. 4, that should be a 2. Thank you. Sorry. Uh-oh. Well, let's see. What is 2 to the 6th? What is 2 to the 6th? Okay. 2 to the 6th is 64. So the 6th root of, if I make 640 64 times 10, we can do the 6th root of 64, right? We just can't do the 6th root of this. And I don't think we can do anything with that a cubed either, can we? So who's going to get out of jail? What's the cubed root of 64? You just told me. 2. And then left we have the, whoops, 6th root. Oh, just keep confusing you. 6th root of what? 10a cubed. Yep. All right. I'm going to let you do these 3. I'm going to give you 2 minutes. Either copy them down and go back to them later so you don't have to get your book out tonight, or actually do them if you get it and can go quickly. But then we need to spend 10 minutes on the pink sheet. Everybody see? Are they big enough? Let's see. This is the pink worksheet you're supposed to pick up in the back. My lovely title for this is Fancy Factoring, because we have to do some crazy factoring with things other than x squareds. Does anyone notice something about the first problem that makes it interesting? Anyone have an idea? Because there's 4 terms. Anybody remember what we can do when we have 4 terms? Nope. We can factor by what's called grouping. Do you remember grouping? So what can I take? No, it's not. That's for factoring cubic. And we are going to need that today. What can we do to these first 2 terms? Okay, and what's left will be? Okay, now for grouping to work, the second parenthesis also has to say x plus 4. So what would we need to take out back there? -1. And what's left is x plus 4. Now, it says in the directions, factor you don't need to solve. They happen to say equals 0, but you don't have to solve, okay? So you can just cross that off and leave it off if you want. I don't care. All right, now how do we factor? Do you remember? The idea here again is you're taking out what they have in common, and they both have an x plus 4 in common. So if I pull that out, what's left over is what? An x squared minus 1. Okay, so we kind of cross this out, and the leftovers get their own parentheses. It's not completely factored, because x squared minus 1 factors how? We had an x plus 4, and this factors how? X plus 1, x minus 1. Okay. On your worksheet, it says there is a similar question in number 9, okay? So make sure you look back at that. All right, I am going to do number 3 next. Number 3, what's happening here? There's an x to the fourth. This is really important concept, guys. This is on the final. You have to be able to factor this. The good news is there's only an x to the fourth and an x squared on this problem. There's no x cubed term and there's no x. So how could I multiply two things to get an x to the fourth? X squared times x squared. That seem okay? Now, what are factors of 18 that you want to try to make a 7? Okay. To get a negative 18, we need either the 9 or the 2 to be negative. You want to try the 9, okay? Now, FOIL this back together and make sure it works. X squared times x squared is x to the fourth. X squared times 2. Negative 9 times x squared and negative 9 times 2. Does that work? Do those middle ones combine to become a negative 7x squared? Okay. So, oh, I almost put a square around there. Are we done? Which one of those two factors further? The minus. Always, it's got to be the difference of two perfect squares to factor further. So that one should factor x plus 3, x minus 3. And this x squared plus 2, even if 2 was a perfect square, when it's a plus in the middle, you can't factor it. So now I can draw a square around it if I want. All right. You're not going to like this one. All right, we're going to do this the same way we just did, except it's going to get painful after that. But what'll make an x to the 6th? That'll also give us an x cubed in the middle. Okay, you want to do squared here, but then we'd need 4 over here, right? It's supposed to get a 6. You're right. We need an x cubed and an x cubed. I was just checking you. X cubed, x cubed. Everybody good? Because that's going to give us a middle term with an x cubed, and the x cubed times x cubed will give us the x to the 6th. Okay. This is not as hard. 125 has a lot of factors, but what's going to give us 124? Okay, 125 and 1. So we have a 125 in one parenthesis and a 1 in the other, doesn't matter which. To have a negative 125 and a negative 124, the 1 is positive. Okay, so if I FOILed that right now, I'd get x to the 6th minus 125x cubed plus 1x cubed minus 125. This would combine. We'd be okay? Everybody good that it's checking? Okay. What do you recognize now, though, that makes you kind of want to cry? These are cube patterns that we're supposed to have memorized. Remember? There's a reason I made you memorize those. You take the cube root of this is what? X plus 1. But what's the rest of it? Do you remember how it goes? This is where the SOAP comes in. You square the first one. In the middle goes 1x. And then you square the last one. 1 times 1 is just 1. But the SOAP is this had the same sign. This gets the opposite. And the sign back here is always positive. So we had a plus, minus, plus. And obviously, if you didn't have the 1 in front of that x, it would be okay. All right. Are we done? We got to do the other one still. Because this is also cubes. How's that going to go?
5.
X minus 5. Now square it. At the back, you'll have a plus 25. But what goes in the middle? A 5 times x, a times b. And if this is minus, it changes to plus. And those will not factor any further, but that is the completely factored version. Okay, guys, give me 10 seconds because 7 is really easy. What is the trick on 7? What can we do first? Always, what was, yes. If we take out an x, we'll have an x to the 4th plus 5x squared minus 6. Anybody know how that will factor? Factors of 6 that make 5. But it's got to be two different signs, right? I think it's going to be plus 6 and minus 1. So are we done? Yeah, this is the difference of two squares. So that one goes x minus 1 and x plus 1. All right. And some of you figured out that, yes, the answers are on the back of this, okay? But that's not going to help you when it's on the final that you have to factor one of these. Oh, were you doing the wrong side? Oh, nice. Okay. So now I know later today when I do this, I will make sure that they're all doing the side that doesn't have answers on it.